Hello everyone, welcome back to my channel. This is Teacher Luis, your mommy tutor. In my previous lessons about organic chemistry, we studied about naming alkenes, alkanes, and alkynes. Okay, so today we are going to discuss more of naming alkenes, alkanes, and alkynes. Okay, but this time we are going to identify or state the reason why the other one is the correct IUPAC or the IUPAC name of the given molecules. Okay, so in this example, the correct name of this molecule is 3-ethyl-5-methyl-heptane. Why is it 3-ethyl-5-methyl-heptane and not 5-ethyl-3-methyl-heptane? Okay, so the reason behind that is, according to the law or rule of naming nomenclature or the IUPAC, is we have to start from the longest chain. So, if we are going to start from the longest chain here, pag mag-start tayo from the longest chain here, we can start here 1, 2, 3, 4, 5, 6, 7. Okay? Or, if we are going to start from here also, 1, 2, 3, 4, 5, 6, and 7. As you can see, they have the same longest chain. So, pareho silang 7, yung carbon group. Okay, now, aside from that, you can also see that the positioning of the substituent, okay? The positioning of the substituent here, dito, 1, 2, 3, is on the third branch, on the third position of carbon. And if we start from here, 1, 2, 3, still the position of the branching of the substituent, it's still in the same position as 3 on the third carbon. Okay? So, if the substituent or the branching, they have the same position at the both ends of the molecule, our basis will be the substituent that has or that comes first on the alphabet, so meaning we have to base it in alphabetical order. Okay, if we name this substituent, this is methyl. Okay, so methyl yan. This substituent is ethyl. Okay? So, since pareho sila ng position, parehong nasa third carbon, even if we start from here or from here, ang basis natin when we name is, we have to start the counting, the least number of carbon from the substituent that comes first in the alphabet. Okay? So, basis natin is the alphabetical order. And ethyl comes first before methyl. That's why we have to use or we have to start counting from this side because this carbon is nearer to ethyl. Okay? So, when we count that, we get 1, 2, 3 ethyl, 4, 5 methyl heptane. Okay, that's the reason why the correct name of this molecule is 3-ethyl-5-methyl-heptane, not 5-ethyl-3-methyl-heptane. Okay, it's the positioning of the substituent. If they have the same position and different substituent, look at the substituent that comes first in the alphabet, or you have to name it in alphabetical order. Okay? So that's the reason. Next, what about if we have this? Okay? In this example, it's an alkene. Okay? According to the rule of alkene, we have to look at where the position of the double bond, always the nearest. Okay, position of the double bond. So if we have to count here, we get, start from here, we get 1, 2, 3, 4, 5, 6. Okay, if we start from here, we'll get 1, 2, 3, 4, 5, 6. So as you can see, pareho na naman sila. Okay, if we start from here, the position of the double bond is on the third. Okay, on the third carbon. If we start from this side naman, the position of the double bond is also on the third. So, pag ganyan, either way. Okay, but then, as you can see here also, there is substituent. Okay, so my substituent, and look at this substituent. They are on the same side again. Both of the substituent are located on the third carbon. Third carbon. Here, the substituent is on the third carbon also. If we start from here, substituent is on the third. Start from here, substituent is on the third carbon. So, pag ganyan, and look at the substituent, different na naman sila ng substituent. The other one is methyl. The other one is ethyl. Okay, so same position of the substituent. If you count on both ends, at the same time, same position also of the double bond. So our last resort here when we name them is you identify which substituent comes first in the alphabetical order. And since this is methyl and this is ethyl, E comes first before the M. And that's why we have to name or count or put the number 1 on this side. Okay, because this side, this carbon here is nearer to ethyl. So we have to name this as 1, 2, 3. 3 ethyl, 4 methyl, and since the double bond is located on the third carbon, 3 hexene. Okay, so that is the reason why. That's why it's 3 ethyl, 4 methyl, 3 hexene, not 4 ethyl, 3 methyl, 3 hexene. Okay, next. Now, what if we have this? Okay, in this molecule, as you can see, this is just a straight one again. And if we count this, we get 1, 2, 3, 4, 5. So it's pentane. So since it's an alkene, there's no double bond. Okay? So if we start from here to there, it's 5. So even if we start from this side, 2, 3, 4, 5. It's still 5. So it's still pentane. Okay. Now, look at the substituent. If you try to look at the substituent, and if you try to count them, still you can see that the substituent are located on the same side again. Okay, same side on the both sides, same side they are located. Okay, and the substituent this time they are the same. Okay, substituent are all methyl. Okay, all the substituent or the branching are all methyl. So if the substituent are the same and they are on the same position, even if you count it on both sides, the basis in naming this formula will be the carbon that has the most branching or the most number of substituent. And since this carbon here has 2 methyl and the carbon in the other side has only 1 methyl branch, we have to start counting from this side. Okay, that's why we will be counting it from 1, 2, 3, 4, 5. We will be using this. Okay, so yun yung gagamitin natin. That's the reason why when we count this, we get 1, 2. So there are 2 methyls here. So we have 2, 2, and then another methyl on the fourth side. Okay, that's why we get 2, 2, And 4, trimethyl. It's trimethyl because there are 3 methyl pentane. Okay? It's not 2,4,4 trimethyl pentane. Okay? Because the one with the most number of branching carbon is this side. So we have to start from there. Okay? Not here. Okay? That is if the substituent, kung yung mga substituent ay pareho. Okay? Don't forget, if the substituent are pareho, the same, and they are located on the same side, when you count from both sides, ang basis mo will be the one with the most number of substituent. Pero if the substituent are not the same, just like what we had a while ago, and still when we count both sides, they have the same positioning, our basis will be the substituent that comes first on the alphabet. Meaning, we have to base it in alphabetical order. Okay? Next. For this one. Okay? What about this one? So, dito, the basis in counting or in naming this molecule is first the one that gives you the longest side or the longest chain. So, we have to count. We can start from here. 1, 2, 3, 4, 5, 6, 7. So, it's 7. It's heptane. Or, we can also start from 1, 2, 3, 4, 5, 6, 7. So, even if we start from here to there, it's 7. Here, over there naman, until there, pag ganun siya, it's still 7. That's why it's heptane. Okay, now, why is this the correct answer? Why this is the correct answer? It is because we have to get the alkane that has the most number of branching. Okay, so if we have to start from here, start counting from here all the way there, we have how many branching? 1, 2, 3, 4. Okay, but if we have to start from here all the way pababa, we only have how many branching? 1, 2, 3. 3, kasi ito straight na yan, and this one is a branch there. So, hindi pwedeng i-base mo na branch ulit yan kasi this is branch from the other branch. Okay? Which cannot be. That's why when we name this, it will be 2,3,5 trimethyl. 2,3,5 trimethyl because we have to start from 1, 2, 3, 5 trimethyl, and then the fourth carbon here has a branch of how many? 1, 2, 3. That's why it is 4-propyl because it has 3 branch. This fourth carbon here has a 3-carbon branch. Okay, that's the reason why this is the correct answer or the correct name of this molecule. Okay, do you understand? Okay, next. What about this one? What is the reason here? Why is this the correct answer? Not this one. Okay, so kapag ganito naman, we always base or give priority to the double bond. Okay, as you can see here, if we're going to name this, we have 1, 2, 3, 4, 5. If we start from here, we get also 1, 2, 3, 4, 5. So, pareho pa rin silang pentene. Okay, they're the same, pentene. But then, our priority here is the location of the double bond. And the location of the double bond is nearer to this side. That's why we have to start counting from here. So, 1, 2, 3, 4, 5. That's the reason why the answer or the correct answer is 4-methyl 1-pentene. Okay? Because we have to start from the double bond, the nearest carbon to the double bond, and it's this one. Okay? Next. What about this? So for this one, 2-methyl, 2-ethyl, 3-methyl, 1-pentyne is the correct answer. Okay, the basis of this one is the location of the double bond. So the I'm sorry, it's not double bond, it's triple bond. So location of the triple bond is this. It's in this carbon. So we have to start counting from here. 1, 2, 3, 4, and 5. Okay? That's the reason why our name is 2-ethyl, 3-methyl, 1-pentyne. Okay? You always start from the triple bond. Okay? The carbon nearest to the triple bond. Okay? Next, here. Now, what if we have double and triple bond at the same time? What are we going to do? So, if double and triple bond is located or is present in a molecule at the same time, you always look at the one with the nearest, the bond, okay, the multiple bond that nearest to the carbon. But if we try to look at this one, pareho sila. Okay, they have the same positioning. If we count from here, we get 1, 2, 3, 4, 5. Okay, so the triple bond is located in the first carbon here. If we have to count from here naman, we get 1, 2, 3, 4, 5. So both of them, they have the location of the double and the triple bond are the same. So pareho. So kapag ganyan, if the positioning of the double and the triple bond are the same, you always prioritize the location of the double bond. Doon tayo mag-start. That's where you start counting. Okay? So, this is the reason why the answer to this one is pent 1 and 4-ine. Okay, by the way, if we are naming a molecule that has both the double and the triple bond, when we name them, we have to start naming with the double band, may whatever be the location of the double band before the triple band. So it should be N-ine. Okay, it's N-ine. Okay, so that's the reason why. So in this molecule or in this formula, we prioritize the double band because both of this one, the positioning of the double and the triple band, they have the same position. Okay, now what if they're not the same in position? Okay, for this one. Okay, so as you can see here, pareho silang may triple at may double band. Okay, they have the same double and triple band. But this time, we don't prioritize the double band. Why we don't prioritize the double band? It's because according to the formula or according to the rule, if there's double and triple band and the position are not the same, we always look at the multiple band that is nearer to the carbon, the starting point, okay? And triple band is the one nearest to this carbon, the starting. Okay, that's why when we count, we have to start counting from here. 1, 2, 3, 4, 5. Not here to there. Okay? It's because when we start counting from 1 here, the double band is located on the second pa, which is farther from the first carbon. Okay, that's the reason why we start counting from this side, because the triple band is nearer to the carbon where we start counting it. Okay, that's the reason why the answer here is pent 3 and 1-ine. So as I have told you a while ago, when we name molecule that has both the double and the triple band, when we name them, you always start naming the one with the N before the ine. Okay? you disregard the position when you name them. Okay, that's only the position is very important when we start counting. Okay, so that we'll know where the position of, or what is the correct position of the double and the triple bond. Okay, but when you write it, the N first comes before the IN. Okay, so that's it. That's the reason. Those are the reason in counting or in naming or identifying the correct name of the molecules in the IUPAC, or in nomenclature of hydrocarbons. So I hope you remember all the rules, and whenever you encounter this kind of test or worksheet, you will be able to get the correct answer. So if you have any question or any suggestion that or lesson that you want me to discuss, feel free to comment below. Okay, again, this is Teacher Luis, your mommy tutor. Please like, share, and subscribe to my channel, and ring the notification bell so that you'll be updated in my next video. Bye!